Hello, my fellow nerdlings. I'm Sean Powers, and today we are going to continue in our series on Bash scripting. And today we're going to talk about conditionals. Conditionals are arguably the thing that makes Bash scripts awesome. Yes, loops are cool and very useful, but conditionals allow the script to do smart things like make decisions, right? Make decisions on your behalf, and nobody likes making decisions, so why not have our scripts do it? Now, in the simplest form, I'm going to show you what an if-then statement looks like in Bash, and then it's just going to get kind of nutty. So let's look at a very simple one. Also, in the description, I will have a link for the GitHub page where I put all the scripts like the sample scripts that we're working on today. I'm going to make them all available so you don't have to like pause the video and type out what we're doing. If you want to just start with the same thing, I'll give you a link to those. But let me show you what a simple if statement looks like in Bash. Okay, so I'm here on just our test machine, and I want to look at a file called basic. And this just gives us this just gives us the most basic if-then statement in Bash. And I'll just kind of show you what is going on. Now, I'll explain exactly how we do everything as we go, and we'll learn how to do this in different ways. But basically, you start with if, and then there's the condition, right? There's the test that you perform to see if the results are yes or no. And if the results of that test after the if are yes or positive or, yes, the true, then it will execute the stuff after then. So the then is here, and then it will say like this is true. You don't have to put the else part. You can actually leave that off. So this, I guess I lied. This isn't the simplest form of an if statement. But if you put the else in there, after the else part, this thing that comes after it, will be executed if the part up here evaluates as false, right? So if it's true, it's going to do the thing here. And it's pretty clear, right? You say if this, then do this. Else, I want you to do this. And then this is just the way that you close the if statement in Bash. You do fi. So it starts with if and it ends with fi. It's backwards. It looks silly, right? But that's just how the whole statement is kind of wrapped up. And that's how Bash knows that we're no longer doing things in the else portion, because you can have multiple lines and Bash will just keep doing the things until it sees the end of the conditional with fi, and then it will go on to the rest of the script. Okay. So what we're looking at here is if, and then it evaluates this, and the test thing is equal to thing. And let's see what happens when we execute this. I'm going to quit. And if we execute it, it says that was true. Thing equals true. And so if we were to change that, we could say as thing equal to, well, I don't know, thing 8. If we save that, now this is going to evaluate as not true anymore. So hopefully that was false. Okay, so that's in its very simplest form, except like I said, I put the else in there, and you don't have to have that. If we didn't have the else in there, just nothing would happen if it was false, right? Because it's saying if this evaluates as true, then do this. And if there's nothing else after it except the fi, if it evaluates as false, it's going to do nothing. It's just going to keep going on by. All right, let's open this back up, because while that is a very simple example of an if statement, that's not usually how it goes. Okay, usually rather than the word test up here, you'll see something like this. You'll see either in brackets like that, or double brackets like that. Now we're going to get a really quick history lesson here. The open brackets and close brackets thing is actually kind of like a link to the test program. So it's doing the exact same thing as if you test whatever's after that, if you put it in brackets. Now the single brackets and double brackets thing, it's a little bit complicated, but the double brackets give you more options inside. It's like an extended set of tests that you can do if you do the double brackets. And those are Bash specific. That only works in Bash. So if you create a script and you want to run it in like SH or TCSH or one of those other shells that isn't Bash, double brackets probably won't work, in which case single brackets will almost always work, and that's called POSIX compliant. It's backwards compatible. It will work. However, I do not recommend that you use single brackets because it eliminates some of the options you have for running tests. And since this is bash scripting and we're always going to do everything in bash and our shebang at the top specifies we're going to use bin bash, we're going to use double brackets because, again, that gives us more flexibility with the kinds of things that we can test. So double brackets instead of the word test and then the test, and that's pretty much all I have to say about that. And so we're here with the double brackets, and if we change this back so that it is equal to, again, we can save this and it should go back to evaluating as true. Yep, because again, the double brackets are just like if we had that test command. So that's the very basics of the if command, but there is so very much more that we can do. For example, let's look at a script called cool. So first of all, here, this is all the stuff that we're going to look at. This is what's in the GitHub repository. So you'll be able to get all of these files. And as you can see, we have a bunch to cover. But let's look at the cool script, which is a script I wrote. And this introduces something that is very useful for an interactive session with a bash script. Okay, this is a way to bring in data, not just like $1, $2 for arguments, but like it will query you to enter data as it runs. Okay, it's a really convenient thing, especially when you're learning and you want to enter different values without editing the script. And it works just like this. So here we have echo are you cool, or just puts on the screen are you cool, and then the read command followed by a variable name. And what that'll do is it'll just wait on the command line for you to enter something and press enter. And then whatever you put on the line there and press enter, that will become the contents of the cool, in this case, the cool variable, okay? And then let's actually walk through this, see if we can see what's gonna happen. So we put something in the cool variable, and then it says if, and then it opens up the double brackets, if cool is equal to, has the contents of yes, then it's going to say, I think you're cool too. And otherwise it's going to say, well, hang out with me and I will make you cool. Okay, so that's what's going on right there. This is a string comparison. So we are just doing a string comparison. The double equal sign like is saying has the value of, and that's why we can do that with a string, the word yes. All right, so let's run this and see how it goes. Are you cool? Yes, I think you're cool too. Well, thank you, script. But if we do that again, and we say no, now the value of cool is going to be no, so it should say, well, hang out with me and I'll make you cool. But there is a problem, right? The problem is, what if I didn't know exactly how to respond? So we'll run it again. Are you cool? Yes. Well, hang out with me and I'll make you cool. See, it only looks for the exact word capital Y, lowercase e, lowercase s. And that's kind of a problem because people might respond in different ways. They might just say Y, for example, or capital Y or lowercase y. So there's lots of options, and we want to be able to check for those. And this is the part of the video where I let you know that the world of bash scripting can be frustrating because there's like 100 ways to do everything, and there's not one that is right or one that is wrong. There's just lots of different ways to accomplish the same task. So I'll give you a few, and you can either use those or come up with your own, because again, there's just so many ways that we could test for multiple things like that. So let's edit this script again, vi cool. And one of the things that we could do is add multiple tests. And we can do that by saying, so what if cool is equal to yes? And then if we do double pipe symbol, that's the one like above your enter key on a US keyboard, shift and above the enter key, it's just the pipe symbol, right? It's a really tall line. That means or in this context. That means if cool is equal to yes, or cool is equal to yes, let's add a couple more, or cool is equal to just a y, and we'll do one more, or cool is equal to just a lowercase y. Let's say they just did that. All right. So with all of those options in there, any one of those should make it evaluate as true. And what we've done is we've just put those different tests inside the double brackets, and we've put an or between them. So this, or this, or this, or this. And if any of those are true, then it will evaluate as true. So let's test it. All right. Cool. Oop, I gotta actually type it out. Cool. Are you cool? Yes, all caps. I think you're cool too. Awesome. Cool. Yes. Traditionally, I think you're cool too. Awesome. Cool. Are you cool? Affirmative. Well, crap. It doesn't test for everything, right? It's not perfect, but we've been able to test for other potential replies. Now we could just add to the echo, like, are you cool? And then give options to them like Y or N, that kind of a thing. And then kind of like show them how to go about doing it in the instructions. But this is how we can also test for multiple things. Now, there's another way that we could test for multiple options. Let me show you. Let's go back into cool again. So here, let's get rid of all this stuff inside the test. Now, this is where we can only do this inside of double brackets, because this is one of the extended things that Bash will allow you to do inside double brackets. This is not backwards compatible with like an old shell or anything like that. This only works in Bash because it requires the double brackets. But what we could do is say if cool is equal to, and then do the at symbol. Let me find my keyboard. At, and then open parentheses, and then put a bunch of options like yes, or yes, or y, or lowercase y, and we'll even add affirmative. If any of those is in there. And what it's going to do is this is using regular expressions basically, and it's saying if it matches any of those, then it will count as true. And so let's run this one. Cool. Are you cool? Yes. I think you're cool too. Are you cool? No. Well, hang out with me. I think you're cool. So it will test for all of those things. I guess I shouldn't have done just the first one, right? Are you cool? Just Y. I think you're cool too. So it looked and it matched one of those, so it evaluated as true. Okay, so that's another way. And of course, there's yet another way. Actually, there's several more ways, and I'm not covering all the possible ways we could do this, but let's go back into there. And one more time, let's say we wanted to test for things, but rather than just do an if statement, actually here, I'm kind of getting tired of this. So rather than using just an if statement with like multiple conditional things, we could use a construct called ELIF, which is kind of like else if. And what that allows us to do is have multiple tests. And let me show you. I have a file here. So vi elif, okay? And I've already typed this all out. So basically what happens here is the same thing. It started the same way. Are you cool? And then it reads that variable in. And then it says if cool is equal to yes, then it'll say, I think you're cool too, right? And, or I don't want to say and because that's actually a word in here. So after that, it says else if, or just elif is actually the syntax that we use, but elif cool is equal to capital Y. Then I want you to say cool people usually use the whole word, but whatevs. And if neither one of those is true, then, well, hang out with me and I'll make you cool. So what this will do is it will test for two different things, but the unique thing about using ELIF is the results are different for each object that you have in there, right? So if it's YES, it will evaluate and say, I think you're cool too. But if it's just a capital Y, it will just say cool people usually use the whole word. And anything else it'll say, well, hang out with me and you'll be cool. So let's try it, but hopefully that's clear what's actually going on. The difference between this and making a whole bunch of tests in the same if statement is that with ELIF, you can give it a different result if it has, based on different inputs or different things that you're testing for. All right, so let's get out of here. We'll run ELIF. Are you cool? I'm going to start with just yes. I think you're cool too. All right. ELIF, I'm going to say capital Y. Yeah. Cool people usually use the whole word, but whatevs. And see, it gave us that alternate reaction. And then anything else that we type, are you cool, blah, blah, blah. Well, hang out with me and I'll make you cool. And that's just another way that we can do multiple tests. But again, this one gives you the option to have different results for the different tests that you're doing. And then lastly, I do want to show you how you would go, like if you have a bunch and you want to test for like a whole bunch of different options, the ELIF statements can get messy and long and cumbersome, right? Well, there's another way to go about doing that. And it's probably a better and neater way to do it. And it's using the case statement. This is not if. This is completely separate from if, but it's a different type of conditional. So let's look. I have a program or a script here all written out. Let's look at the case program. We're going to start the exact same way, okay? It's going to read in the variable cool, and it's going to say, are you cool? But here's where it varies and gets a little bit different. See where it says, instead of if, it says case, and then the variable that we're testing and then the word in. So case cool in, and then we have the different results that we're looking for, or the different possibilities or potentials that we're looking for. And it's basically the thing we're testing for, and then parenthesis, like close parenthesis, and then all the lines after here are going to be executed. So this actually has 2 in here. If you answer yes, all in caps, it'll say, nice, stop yelling. And I think my ears are bleeding. If you say yes the normal way with the capitalized Y, then it'll say, nice, me too. And Y. And then the last one is the asterisk. And that's basically a catch-all. It's like, okay, if anything else is in this cool variable, like it doesn't match anything else, it's like the catch-all at the end, then say that's okay, hang out with me, and you'll get cool. Okay, so hopefully that makes sense. The other thing I want to point out that you may have missed because I didn't point it out yet, see how we can have multiple lines here? That's not a problem. However, the way we denote that we're finished with this section, if you will, is by putting a double semicolon at the end of the final statement. So like this one only has a single echo statement, and you put double semicolons at the end there. So it's really important that that's how you end each segment. Otherwise, the program doesn't know that that segment is over. Okay. And same thing down here. It ends with the double semicolons. And then you remember how if started with if, and then you had the then and the else, and at the very end, it was fi. And that's how it ended, so that Bash would know that you're done with that statement. Case is exactly the same, but it just looks ridiculous because it's like a longer word. So it starts with case, and then when you're done, ESAC, which is case backwards. See how that, I mean, if you weren't looking for it to be backwards, that's a weird word to have in the middle of your script, but ESAC is how you end a case statement, okay? So hopefully this looks good. Let's try out a couple of these because it will function the same way as an if statement with ELIF in there as well. Let's see. So case, are you cool? Yes, all in caps. Nice. Stop yelling. I think my ears are bleeding. Remember, that was in there. That's what we would expect. Let's run case. And now we're just going to say capital or lowercase y. If cool means the minimum possible effort, maybe, because I guess I was being silly. I didn't pay attention. But lowercase y is the least amount of effort, and very cool. And if we do anything that wasn't listed in there, that asterisk is going to catch it. And the catch all is what's going to be put. Oop, sorry, not as an argument. We got to wait for it to prompt us. Are you cool? No. That's okay, hang on with me, and you'll get cool. Okay, so it's the same end result. It's just done in multiple different ways. And a case statement is much more easier to read if you have a whole bunch of them down a row instead of a lot of ELIF, 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 ELIF kind of things going down the page. But you have to remember, it's case and ESAC at the bottom. And I mean, it makes sense now, but otherwise ESAC, like I said, is a weird word to just have in the middle of a script. Okay, and there's one more string test kind of scenario that I want to demonstrate and show you, because sometimes you want to group statements together. Like we did that long thing with like this or that or, but sometimes you want to be like one of these two and this one. And let me show you what I mean, because I have a script here. It's called name. So let's look at the name script. And this actually prompts for 2 variables. Okay, it says, what's your first name? And then it reads in the variable first. What's your last name? Reads in the variable last. And then it creates, it's just a single if statement here. There's not even an else, but it says, okay, if the first name variable is equal to Jane, or the first name variable is equal to Susie, and notice how they're in parentheses here. That's really key because that separates them. Actually, what happens is when you put something in a set of parentheses in a shell script, it actually starts a new shell, evaluates it, and the results are replaced with, in that spot. So whatever the results are of this first name equals Jane or first name equals Susie, if that's true, then it will just return the result true. So just one of those has to be true, and then that section in the parentheses is going to turn out as true. And then 2 ampersands next to each other is the way we say and. So one of these has to be either Jane or Susie, and the last name has to be Smith for this whole statement to evaluate as true. So look at that kind of slowly. Hopefully that makes sense. We've grouped these together. So one of these has to be true and this has to be true in order for it to evaluate as true. And then the results are, if you are Jane Smith or Susie Smith, then you might be one of the Smith twins. Okay, so let me get out of here and we'll run this really quick. And the results should be just what we expect. What is your first name? Sean. What's your last name? Powers. Nothing, because there was no else statement, right? And it didn't match because my first name isn't Susie, or what was the other one? I don't remember. Jane, I think. And my last name is not Smith. But if we were to run that as, and that be one of our names. So what is your name? Susie. What's your last name? Smith. You might be one of the Smith twins, because the Smith twins are named Jane and Susie Smith. So anyway, that's a way that you can group tests inside so that your conditional can test for more than just an and or an or. It can like group them together, and hopefully that makes sense. It's useful in some situations, and it makes it a lot simpler than like constructing long like nested if then, because you could also put like an if then inside of an if. It can get really complicated. Again, remember, there's like 100 ways to do the same thing, but the nice thing with those parentheses is that you can group them, and it makes it a lot simpler and pretty easy to read. When you look at it, it's pretty clear what's going on. Okay, anyway, that's string comparisons. But a lot of times what we want to do is test for things on the system. And the first one that I want to talk about is file system tests. Okay, and what I mean by that is you can actually query the file system itself and say, does this file exist, or does this folder exist, and things like that. And that's a way that we can do a conditional. So let me see, I have one that started, I think it's called file check. So let's look at file check. Yeah, okay. So inside here, there is, it's just this. So if, and then we have the double brackets again, and then instead of comparing something, we just do a -s. And what -s means is if it exists and it's not empty. Okay, I will, let's see, I have a cheat sheet right here. I'll paste these into the description as well, because these are just things you kind of have to remember, or honestly Google if you're making a script like, okay, how do I test if a file exists or whatever? And this is a great way to go about doing it. But -s tests for if it exists and it's not empty. And this can be a file or a directory, but it's important to note that we're talking about file size, and I'll show you in a second. So, okay, it's testing for something called test, and if it finds something called test, it'll say this is true, and if it doesn't find something called test that isn't empty, it'll say this is false. So let's quit. Is there something called test? No, I don't have anything. So first of all, let's just run it. File check. This is false. There's not a file called test. But if we were to touch a file called test, we'll see now it's there. We can see it at the end. It exists. But if we run file check, it's still going to say false, because remember, it's empty. It has to have something in it for the -s test. And if we do ls-l, we're going to see it has a file length of 0. Okay. So if we were to say like echo blah into test, now we can see that it has 5 bytes in there. So now if we were to run file check, it should say, yes, it was true. There's a file called test and it is not 0 length. But the directory stuff is a little bit more confusing with the -s test, because let's get rid of test here and let's create a directory. So mkdir test, and there's nothing in there, right? We just created it. So it's an empty folder. So you would think that file check would report that it's false, but it says it's true. And that's because it looks for file size, or it looks for the file size like it did up here when it was 0 and then it was 5 when we put stuff in there. But if we look ls-l, a directory has a size. Okay, just by its very existence, it has a size. And so that's why the test sees it as non-empty. So hopefully that makes sense. The emptiness that it's looking for is the file size, and a directory has a file size on the file system. All right, so dir, test. Okay, and that is how we can test for a file. But there's a couple other ones too. Let's look up file check. So instead of -s, I'll just go over a couple of the common ones that you might want to use. You can do -a or -e. They do the exact same thing, and they do the same thing because it's being backwards compatible. Years ago, you had to use, I think, -e, or I don't know, one or the other. One is newer than the other, but -a and -e both do the exact same thing. All they do is check that the file exists. They don't care about if there's any size to it or anything. So we'll just do this one. And now, if we do file check, it's going to say it's false. But if all we do is touch it and then run file check, it's going to say it's true because it doesn't check for file size. It just checks if it's there. So whether it's a file or a directory, boom, it's going to check to see if it's right there. All right, so let's get rid of test. But sometimes you want to specify file or directory, right? And that's where we can go. Instead of -E or A, if we do -F, this is going to check for a file, if a file exists. It doesn't check for size, I don't think. It just checks if it's an actual file, not a directory, not a symbolic link, but an actual file. And if it is a file and it exists, then it will return as true. So we do this, if we touch test and we do file check, it's going to say it's true, it exists. It doesn't care that it's empty. If we get rid of it though, and mkdir test, and now if we run file check, now it's going to say it's false because remember, it tests to see if it's a file. A directory does not count. Okay, so rmdir test. So that checks for files only. And of course, there is one to test for directories. Oop, that's not what I want to do. There, edit it. Instead of -F, you probably have guessed what this one is. -D will test for a directory to see if something is a directory. And this is the last one that I'll do. This is just, it's useful if you're looking if something exists. Like a lot of times, if the script runs, if it exists, you might want to load the contents of it into a variable. If it doesn't exist, you might want to create it. So that's why you would need to have conditionals to test for stuff like this. But what did I do? Did I do, oh, I did a directory, right? Yeah. So if I were to touch test and run file check, it's going to say false. It's there, but it's not a directory. If we get rid of test and then make a directory test, I mean, you can see where this is going to go. It's going to say true because it checks for whether or not it's a directory. And that is, again, those are the things that you would do to see if like you already have a file in existence, like a config file. And if the config file that you're trying to read in doesn't exist, you might want to create it, but you would need to test to see if it's there so you don't write over somebody's config, that sort of a thing. That's really useful and something they actually do kind of use often inside of a bash script. Okay. The last thing that we're going to look at is using math or arithmetic inside of a bash script. This is a general frustration about bash scripts. You must use integers when you're dealing with like conditionals and stuff. Bash is really not great at float variables or like variables with a decimal or anything like that. It wants whole numbers, integers, and so we're always going to be comparing integers with bash. It's just the way it is, okay? And if you have to work with floats, there's other programs that you can use and call into bash, but the bash tools themselves are going to rely on integers. And when you're doing comparisons and conditionals, it's going to be integer to integer that we're going to be comparing. Okay, so with that in mind, let's go do some math. All right, now I have a file in here. It's called math, oddly enough. So let's look at this math variable or this math script. And what this is going to do is it's going to load in some variables using that read command, just like we did before. Give me a number, first number, give me another number, second number, and we compare them basically. Again, double brackets here allows us to compare one number to another number. And the thing that we put between them, and I'm going to put a list of these in the description too. We'll look at a couple of them, but it's basically, this stands for equals to. We could do like LT for less than, GT for greater than. They're pretty clear. LE for less than or equal to. And if we use the double brackets here instead of single brackets, remember we're always going to use double brackets, we could use like the equal symbol or the greater than symbol, but that's not backwards compatible. The backwards compatible way to do it is using these dash and then two letters. But anyway, what this is going to do is compare them. And if they're the same, this will evaluate as true and it's going to say those are the same. And otherwise, if they're not the same, it's just going to say those are nice numbers. Okay, so let's run this math. Give me a number, 1. Give me another number, 1. Those are the same. All right. Let's give me a number, 1. Give me another number, 2. Those are nice numbers. But remember I said that integers and stuff, it's important. So give me a number 1.25. Give me another number, 4. Error, right? It has to be an integer. And if you want to make sure that you don't get errors like this, you're going to have to do error checking and convert the numbers or round them and do all sorts of elaborate scripting to turn them into integers so you can compare them. Hopefully that makes sense. Now let's do a couple of others just because we can. let's see, those stay the same, but instead of this, we'll say if first is, so I'm going to actually do this, equal to or greater than the second. So if it's equal to or greater than the second, we will say, it's not going to be true that they're the same. Oh, they could be, I suppose. Ooh, first is bigger or the same. And if it's not, then first is tiny. All right, let's see if my logic works. I didn't think really hard through that, so hopefully I didn't mess that up. Give me number 1. Give me number 2. Oh, I messed up. Dang it. Oh, it has to be in the other order. It has to be the greater than sign and then equal to. Greater than equal to. That's why I generally don't use those symbols. Generally, I will use the commands like I showed you. So greater than or equal to, and that will work. Otherwise, I could do greater than equal to. That's why it messed up, because I put it backwards. I'm going to do greater than equal to. Math, 1, 2. First is tiny. All right, let's see. 3, 3. Ooh, first is bigger or the same. And then let's do the other one. 5, 1. Ooh, first is bigger or the same. Okay, so that works. And we can do a bunch of them like that. I'll do one more because I messed up. All right, fair enough. We will do not equal. Okay, I'm going to do it using the symbols because we're in double brackets, and the exclamation means not equal. Okay, so if the first is not equal to the second, then we're going to say those are different, and I spelled it wrong, and I don't care. And otherwise, we're going to say, cool, similar numbers. All right, so now let's run it again. Give me a number 1, give me another number 2. Those are different. And let's make sure that it evaluates right if we do the same number. Cool, similar numbers. Okay, so that's how you can do it. And it's dash, like greater than equal to, dash GT for greater than. And then if you want to use the symbols, you have to say the equal sign first, right? Like equal than or greater, or no, greater than or equal to. Oh my goodness, I keep saying it wrong. Or not equal to, greater than equal to, less than equal to. You can use those symbols, but I generally use the letters, and apparently it's a good thing because I screwed it up as I tried to type them in there. All right, so that's how we compare numbers. And I know this is getting to be long. We're almost done. I want to show you how you can do some math inside of your conditional stuff. So let's look at double check. This is another script, and same thing. We start with the first and the second. We load those variables, and then we do some multiplication inside our test here, right? And to do multiplication, you do $sign and then double parentheses, and then you do whatever commands you want. In this case, I'm multiplying the variable first times 2, and then I close those double parentheses. So if the first variable times 2 is equal to the second one, then it will say the second is double the first. Otherwise, it'll say those are nice numbers. All right, so you have to put it inside double parentheses in order to do arithmetic. Hopefully that's clear. So we're going to run this. Double check. Give me a number 1. Give me a number 2. The second is double the first. All right, let's do it again. We'll do 3 and 6. The second is double the first. We do it one more time. 4 and 1. Those are nice numbers. Okay, so that's how you can do some simple mathematics inside there. But again, it's all integer based. We're not gonna do stuff and get decimals. It does funky things with decimals. Sometimes it'll truncate it. Sometimes it'll give you an error. So mathematics is frustrating. And then that's it. I just want to show you this one last thing. And this is how you can do conditionals with the, what is it called? I think it's called just short notation. Okay. This is a little bit confusing. You don't ever have to use this, but you might see it somewhere on the internet. And so I wanted to prepare you. Okay. So we're not even going to do it inside of a script. I'm just going to do it right on the command line because we can do an entire if-then statement, if-then-else statement on the command line. What we do is we'll start with double brackets. 1 is equal to 1, and then you do and, so ampersand, ampersand. So if that is true, then echo true. And then or, so pipe, pipe, echo false. So if 1 is equal to 1, it should echo true. And if 1 is not equal to 1, it should echo false. It echoed true. So let's do the same thing, but make it not true. False. Okay, that's just called short notation for doing an if-then statement. I don't like it that much because it's hard to understand what's actually going on. But if you see that, it's actually doing an if-then-else statement with that one quick line right there. Now, I know that was a lot to cover, but take your time and I'll have the GitHub link to all these files so you can download them and play with them yourself and modify them yourself. I know that it was a lot to cover, but I wanted to have one video that would cover all of the conditional things so that you can use case statements or if statements or if then else or ELIF or all of those things that you might need to do with arithmetic or file system checks or string comparisons, all that stuff. You have one resource to learn all of the conditional stuff. So anyway, I hope that you found this helpful. And again, watch it again or download the GitHub thing. Most importantly, I want you to learn everything. Do what you love. And most importantly, be kind. I'll see you at the next Bash video where we're probably going to start loops, which is the next really super cool thing. But I'll see you then. Please leave comments if you found this helpful, if it was too long, if I should have broken it up. Just let me know what you think in the comment section, and I will see you next time.